the scale of the solar system, and you may not have known that the solar system had a boundary. For example, here's the Sun, and here's where the Earth is, about 1 centimeter away. There's Mars, there's Jupiter, Saturn, Uranus, and Neptune. And this Voyager spacecraft is about, oh wait, beyond the end of my arm here. So it's about 122 centimeters. While this is just Earth and the Sun is 1 centimeter, Voyager 1 is over 15 billion miles from Earth. And something just changed. According to engineers, the data coming back isn't behaving like anything we've seen before. After traveling for nearly 5 decades through the void, NASA's most distant explorer has revealed anomalies that have left scientists stunned. The spacecraft has likely crossed into, some scientists believe, Voyager is no longer just outside the solar system, it's in an entirely different domain of space-time. The subtle distortions in signal patterns and unexpected particle readings suggest we're getting our first glimpse of truly alien territory, a place where even the laws of physics might operate differently than we've understood them. When Voyager 1 crossed what we call the Heliopause in 2012, scientists expected to see a clean, dramatic shift in the magnetic field. But that's not what happened at all. The magnetic fields didn't rotate the way we expected. Instead of the sharp directional change that would signal a clear boundary between our solar system and interstellar space, Voyager detected something much stranger. What the spacecraft found wasn't a wall at all, but what NASA researchers now describe as a twilight zone, dense, tangled, impossibly alive with strange magnetic structures. This region displayed properties unlike anything we'd predicted. Scientists discovered bizarre magnetic highways where particles could flow both in and out along reconnected field lines, creating passageways between our solar system and the greater galaxy. The plasma density and particle flows were chaotic, almost like Voyager entered a cosmic traffic jam of unknown origin. When the spacecraft's instruments recorded the plasma density, they found a dramatic jump that was 10 times higher than expected. But the real mystery was the erratic, unpredictable way these particles moved, defying simple models of how the boundary should work. Scientists now suggest the boundary may be a topological phase change, a structural shift in the shape of space itself, like how water transforms into steam. This wouldn't just be crossing a line but entering a fundamentally different state of cosmic reality. The heliopause might not simply be a boundary in space, but a critical point where the very nature of the medium transforms on a fundamental level. Perhaps the most unsettling discovery came in recent years when NASA engineers noticed something subtly wrong with Voyager's communications. The signal timing is subtly off, not enough to alarm, but enough to notice. The timestamps and communication delays don't perfectly match what we'd expect based purely on distance calculations. It's as if time itself flows differently where Voyager now travels. Theorists propose it's due to plasma lensing, gravitational frame dragging, or even non-linear time flow at the boundary. Meev Ofer from Boston University suggests that these anomalies might be caused by the interstellar medium bending space in ways we haven't accounted for. The radio signals from Voyager must pass through regions of magnetized plasma that could create tiny but measurable distortions in how information propagates back to Earth. Some researchers believe Voyager may now be bending time and signal through unseen distortions in the local interstellar medium. As the spacecraft passes through zones of varying plasma density, its radio transmissions experience phase shifts that hint at relativistic effects we never expected to observe at this scale. These timing anomalies raise profound questions. Is Voyager encountering boundaries in space-time itself? If you're finding these revelations as mind-blowing as we do, don't forget to subscribe. What's truly shocking is that Voyager's cosmic ray detector has started picking up anomalous particle signatures, isotopes and energies not explained by solar or typical galactic sources. These aren't just regular cosmic rays. They have unusual energy distributions and compositions that don't match anything in our standard catalogs. Scientists at NASA's Jet Propulsion Laboratory have been working around the clock to understand what these exotic particles might be. Some scientists believe they could be traces of supernova debris or even remnants of early galactic formation. The geological record on Earth shows evidence of iron-60 deposits, a radioactive isotope that can only come from supernovae. These deposits suggest our solar system passed through the remnants of exploding stars roughly 5 to 10 million years ago. Could Voyager now be encountering particles from these same ancient stellar explosions? Others suggest strange baryons or heavy elements seeded into the local bubble could be responsible. Dr. Edward Stone, the longtime project scientist for the Voyager mission, noted that these particles might represent matter that formed under conditions we simply cannot replicate on Earth. The extreme energies and densities of the early universe or massive stellar explosions could have created these exotic particles now drifting through the interstellar void. It's a kind of galactic archaeology, buried in high-energy space. Each particle Voyager detects carries information about cosmic events that happened millions or even billions of years ago. Plasma readings show another drop in density. Some suggest Voyager is approaching a hypervoid, a vast, almost empty zone between interstellar clouds. After crossing the heliopause, scientists expected Voyager to find a relatively consistent density of interstellar matter. Instead, the probe's instruments reveal that the particle count is plummeting again, as if Voyager is heading into an even emptier region than we anticipated. This may be the most sterile, silent region of the galaxy we've ever measured, a test bed for dark energy effects. In these extraordinarily empty regions, the fundamental forces of nature might express themselves differently. With almost no matter to interact with, the subtle influence of dark energy, the mysterious force accelerating the universe's expansion, could potentially be measured more precisely than ever before. Could this be the first time we measure cosmic constants outside the Sun's gravitational domain? For all of human history, our scientific measurements have been taken within the Sun's sphere of influence. Now, Voyager offers us the unprecedented opportunity to test whether physical constants truly remain constant in the depths of interstellar space. If these values differ even slightly from what we measure on Earth, it would force us to rewrite fundamental physics. But there's another layer to this mystery, one that suggests the region Voyager has entered might be more than just uncharted. It might be fundamentally different from anything we've encountered before. NASA engineers have noticed odd periodic wobbles in the signal phase, not noise patterns. The radio transmissions coming back from Voyager 1 display subtle but distinct fluctuations that repeat in ways that can't be explained by random interference or instrument degradation. These signals display a mathematical precision that suggests something fundamental is affecting how information travels through this region of space. Some believe this could be caused by rogue mass concentrations, maybe a dark matter filament, maybe plasma instabilities. Dr. Suzanne Dodd, Voyager project manager at JPL, pointed out that these signal anomalies might be our first detection of hidden structure in the interstellar medium. As Voyager's radio waves travel back to Earth, they could be passing through unseen concentrations of mass that bend the signals in measurable ways. Voyager may be brushing against a gravity wrinkle, a real-world warping in the fabric of interstellar space. Einstein's general relativity tells us that mass bends space-time, but we've never had the opportunity to measure these effects in the depths of interstellar space. The consistent patterns in Voyager signal distortions hint at the spacecraft encountering regions where space-time itself is being subtly stretched and compressed by forces we can't directly observe. These signal distortions aren't just communication issues, they might be our first glimpse at the hidden architecture of the cosmos itself, revealed only because we've sent a messenger far beyond where humans were ever supposed to reach. Voyager 1 and 2 exited at different points in the heliosphere, yet their data shows uncanny symmetry in field strength and density patterns. Despite Voyager 1 crossing the Heliopause in 2012 and Voyager 2 following in 2018 at completely different locations, both spacecraft recorded remarkably similar patterns in magnetic field intensity and plasma density. This symmetry shouldn't exist if the boundary were as chaotic and irregular as we originally thought. It suggests hidden symmetry laws governing our Sun's interaction with the galaxy. These symmetries hint at fundamental properties of how magnetic fields and plasma interact at the boundary between stellar and galactic environments. Some physicists speculate this could be evidence of a deeper organizing principle in astrophysical systems, perhaps tied to the same mathematical structures that govern quantum systems and particle physics. And what if this was a one-way trip all along? What if Voyager has crossed a threshold that nothing can return from, a boundary that fundamentally separates our solar neighborhood from the true wilderness of interstellar space? Some models show the outer heliosphere might be wrapped in an asymmetric magnetic shell. Recent research from aliophysicists suggests that the boundary Voyager crossed isn't just a simple threshold, but a complex directional structure with different properties depending on which way you're traveling through it. The magnetic field lines at this boundary appear to create a one-way membrane of sorts. Anything that exits it, like Voyager, may never be able to re-enter the solar system the same way due to the magnetic reconnect ion patterns at the heliopause. The pathway Voyager took to leave our solar system effectively closes behind it. The magnetic field lines that temporarily connected to allow passage out would snap back into their original configuration, sealing off the exit route. This creates what physicists call an irreversible transition, a change that cannot be undone by simply reversing direction. Voyager may have passed a point of no return, entering a domain completely cut off from home. This gives profound meaning to the idea that Voyager has entered a region we were never meant to reach, because nothing from our solar system was ever meant to exit and return. It's not just distance that separates Voyager from Earth now, but a fundamental change in the structure of space itself. The spacecraft has become the first human-made object to truly leave home forever, entering a realm that may operate by different rules than the space we evolved to understand. It's now entering the pristine interstellar medium, unshaped by the Sun's influence. After decades of traveling through regions still partly influenced by our star, Voyager 1 is finally reaching truly undisturbed galactic space. Here, the particles, magnetic fields, and radiation come not from our Sun, but from distant stars, ancient cosmic events, and the broader structure of the Milky Way itself. This is the environment that exists between star systems, the true cosmic ocean. Beyond lies the local bubble, and potentially the shockwaves of ancient supernovae we only recently found traces of on Earth. Our entire solar system sits inside a vast, hot cavity called the local bubble, created by multiple supernova explosions over the past 10 to 20 million years. Geological evidence on Earth shows deposits of iron-60, a radioactive isotope produced only in supernovae, proving our planet was showered with stellar debris from these explosive events. Voyager is now traveling toward the edges of this bubble. Voyager could eventually encounter ghost particles from stellar explosions millions of years ago, like iron-60 or heavy actinides. These particles, remnants of stars that died long before human civilization began, drift through interstellar space like cosmic fossils. Voyager's particle detectors might someday register the direct impact of these ancient stellar remnants, giving us a tangible connection to cataclysmic events that shaped our galactic neighborhood millions of years before we existed to witness them. Beyond all these discoveries lies the core story of Voyager 1 itself, which remains extraordinary even without the more recent mysteries. Voyager 1 was launched in 1977, flew by Jupiter and Saturn, and was the first to cross the Heliopause. Originally designed for a planetary tour, the spacecraft used Titan's gravity to sling itself onto a trajectory that would eventually carry it beyond all known boundaries of our solar system. It passed the termination shock at $94, entered interstellar space at $122 in 2012. The termination shock is where the solar wind dramatically slows as it begins to feel the pressure of the interstellar medium. Beyond this lies the Heliopause sheath, a turbulent region where solar and galactic influences mix, before finally reaching the Heliopause, the true edge of the Sun's dominion. When Voyager crossed this boundary in 2012, it became the first human-made object to enter interstellar space. Today, it's nearly $160 from Earth and still sending back data. Its mission will likely end by the late 2030s. Despite dwindling power from its radioisotope generators, NASA engineers have extended Voyager's life by carefully managing its remaining energy resources. Each bit of data it sends takes over 21 hours to reach Earth, traveling at the speed of light across vast cosmic distances that continue to grow with each passing second. In 40,000 years, it will pass near another star. It may outlive Earth as the last human artifact floating in deep space. Long after its power fails, Voyager will continue its silent journey through the Milky Way. In about 40,000 years, it will drift within 1.7 light-years of the star AC plus 79,388. And far beyond that, models suggest it will orbit our galaxy for billions of years, potentially outlasting Earth itself, as humanity's most enduring physical legacy. If you found this discovery fascinating, you won't want to miss what Voyager 2 is about to enter next. The second of our interstellar messengers is now approaching regions that could reveal even more surprises about the structure of our cosmic neighborhood. Every day, both Voyagers push deeper into uncharted territory, sending back data that continues to challenge our understanding of the universe. Subscribe and turn on notifications so you're always the first to know when these ancient spacecraft encounter something truly unprecedented. With each passing year, these remarkable machines venture further into a realm no human creation was ever designed to reach, continuing humanity's greatest journey of exploration.